Welcome to Luxoft Tech Talks, a series of podcasts in which IT gurus share their knowledge and discuss the latest trends and innovations in the world of IT. We are going to cover the most recent developments in the programming languages, frameworks, and technologies that are shaping the future of the software industry. This new format of online learning is part of Luxoft Learning Management and Development Services rebranding. Please share your feedback in the comments to let us know what speakers and topics you would like us to cover in later installments.
Welcome, guys. Thank you for joining us to this talk and to this presentation. Today, we will talk about a little bit regarding reactive programming. We will talk about some, like an introduction about reactive programming and how can we start working with using Spring, Kotlin, and also reactive programming together. My name is Cano. I'm senior software engineer here in Luxoft, and I'm very happy to have you here in this talk. And our agenda that we will cover today, we will talk about, obviously, about what is Spring, then what is Kotlin, then we also talk about a little bit regarding reactive programming, what is reactive programming, the principles, and how all the things are connected together. We'll try to do a small demo, and then we'll cover some questions about all the topic, all the talk that we'll check right now. So, in what's Spring? Well, Spring is the most popular backend framework for Java. This framework born and was released on 2002. Was created by Rod Johnson, the Spring's fathers, and he delivered the framework also with his book. This book that I really recommend you to check it out because it's are the basis for Spring, and Rod Johnson explained a lot of things of how Spring was created and why was the main reason of Spring was created on those days. I don't talk a lot about it because it's a huge topic, and also it's a topic that you can check offline. And the current version of Spring actually was released this month. Is the version 5.2.6 and the version 2.3.0. Why we have two versions? Well, the version 5 is for Spring Core and for all the framework, and the version 2 is for Spring Boot. That is an extension, or is a new module that was delivered a few years ago. And Spring Boot basically is the capability to create single-jar applications, and based on all the powerful things that Spring have inside of it. With dependency injection, and work together very, very easily. Spring provides us a huge environment to develop different standard applications and also web applications. And right now, we'll talk about how we create reactive applications using Spring 5, and also Spring 2. We'll talk a little bit deeper in the last slides. Well, what is Kotlin? Kotlin is relatively a new language that born and was released on 2011, and is also a statically typed programming language like other language. Even Java is also statically typed programming, and it runs inside the Java virtual machine. And today, in these days, Kotlin is very popular using to create Android applications, and also you can use it even for create native applications, or even JavaScript applications. It's a huge topic. It's very interesting. I really recommend you to check all the documentation about Kotlin. The most important thing is that Kotlin runs inside the Java virtual machine, and is very is retrocompatible between Java and Kotlin. We can create a mixed Java classes and Kotlin classes, and we can have those classes together inside a project. Actually, in our current projects here in Luxoft for our different clients, we are using Kotlin, and also we are using Reactive programming, also we are using Spring 5, and we work with both languages. The version until April 2020 is the 1.3.72, and well, Kotlin have other very powerful feature that is it supports and is very friendly with both paradigms of programming, object-oriented programming and functional programming. Something that is very good for Kotlin, and also we can explore, and also we can use a lot, is that Kotlin is more concise. Comparisons between Kotlin and Java are that basically we can cut the 30% of lines from Java by using Kotlin. And yeah, you can think that this will be faster for development. I think it's faster for development when you are becoming an experienced programming in Kotlin, and it's very good for to create new applications and also to migrate applications. We talk about a little bit about the difference, not so in deeper, but we'll talk about what are the major difference or the benefits that we have using Kotlin against Java. And well, the first of the things is that Kotlin tries to solve this popular error, that is the billion mistake error, that is the null pointer exception. Kotlin by its nature is trying to solve dot to null, because by out of the box, Kotlin don't support nulls. If you need to use nulls, you need to specifically say to Kotlin that this type is null. We will check it in the demo that we'll check a little bit later. We have extension functions. Extension functions is also another huge topic, and is very good. What I can say is that extension function is the capability to create only a extension of a single, in this case, method that we have in Java. But in Kotlin are functions. We can extend for another function and only pursue that function, not to inherit from all class and extend all the class. We also have coroutine supports. Coroutines is also a very cool topic. I really recommend you to check it out. Coroutines, we can say that coroutines are like lightweight threads, as we know in Java, and is lightweight in Kotlin, and also the support of Kotlin coroutines came to Spring recently. We have recently the Kotlin support coroutines for in Spring. And we don't have checked exceptions. That is also a very nice topic. We have data classes. Data classes that is another very good feature of Kotlin that also we will use it in the demo. And well, data classes, basically, if you are using you have a chance to use Lombok, is very similar that to have an add data annotation inside a Java class. And the cool thing is that in Kotlin we have it out of the box. We have a mask cast type inference that in Java 10 we have type inference. Well, Kotlin have it since start the language, and obviously we have all the powerful features of functional programming, because Kotlin is very, very functional, and you can use it in that paradigm. And the cool thing is that we have, or we can use it both paradigms, functional programming and object-oriented programming. Okay, what is reactive programming? Well, reactive programming is not a new topic. I know that in these days, it's becoming so popular because we have a lot of applications, new applications that are running as a reactive, and also we have this third topic that also is named non-blocking IO, that we will talk a little bit deeper. And well, it's a microarchitecture that the major feature of of reactive programming is the usage of events and consuming events. And the idea is since around the 70s, which you know is not a new topic, but fortunately in these days it's becoming so popular and we are using it a lot because we can exploit more the capabilities of the servers and also more the capabilities of computers or in the computation. Okay, a lot of languages are multi-thread. Java is the most popular of them. I can say that Java is the king of multi-threading, and Java have been the king for a lot of years. And multi-threading is good, but it has a huge lag. The threads are blocking I/O. So what is the meaning of blocking I/O? Basically, if we check the basis of web components in Java Web, when we receive a request, we have that request and we have the payloads, and also we get the information inside our web container, and then we can pass through different methods and also different processing in our web container. And then to respond, we use the same thread in order to respond that information. Basically, we receive a new thread from the web container, and that thread tries to solve the request, all the processing that involves that request, and then the response. We use one single thread. The essence of non-blocking I/O is to use, especially talking about Java, because Java also use non-blocking I/O since RX Java was implemented. The sense of using non-blocking I/O is to manage events and use another thread to do the response and to do other processing. We can have a thread pool that does thread pool can resolve different requests and response dynamically. That is the sense of non-blocking I/O. And well, in order to understand more what is reactive programming, we go to the bases. The bases are this design pattern. This design pattern that is one of the 22 design patterns described in the book of design patterns. If you remember, or if you don't know, we have three major design patterns at class level: creational, structural, and behavioral. And we have the observer pattern. This observer pattern, if we try to do a comparison between Twitter and this design pattern and this design pattern, we have that if we are scrolling down throughout throughout Twitter, we can be subscribed, or we can we are the followers for different people in Twitter. So we scroll down and we check the tweets, and basically that is happening is that I'm the observer, that I'm checking the subject tweets. And well, this is the sense of the observer design pattern. Basically, there are a lot of observers. I can be included in that as observer, and there is a subject that the subject is sending tweets. Is the sense of the observer design pattern. But there is a variant. There is a variant, and also there is another pattern that we have in that this pattern is the one that is based the reactive programming, and is the public subscribe pattern. There is a difference between the observer, because if you are an observer and you are not subscribers, you are following a subject, we only are checking, let's say, talking again with the Twitter example. You're scrolling down, you check tweets, and that's it. The publish subscribe pattern is based on a publisher and also subscribers, but the difference is that we have a subscribe channel. If we, again, try to apply a real example, this is very similar that we have in YouTube. You are a user of YouTube, and there are YouTubers that they create a channel, and that channel they post their videos, and you need to subscribe to that channel in order to get the notifications about new video. That is the sense of the publish subscribe pattern. A publisher sends a message. In this case, the publisher sends a new video into YouTube. If you are subscribed to that channel, you can receive that notification, and as a subscriber, you can see the message, in this case, the notification for the new video, and you can watch that video. That is the sense of the publish subscribe pattern. That is the sense of the reactive programming that we know reactive programming. Okay, and how Spring, Kotlin, RX are connected? Well, I didn't talk a lot about reactive programming in RX Java, but I think I have another slide here. Well, RX Java or Reactive X, that is known right now, born because this guy, Eric Meyer, created Reactive extensions for .NET in 2010. And Eric Meyer, that was an engineer in Microsoft, put the basis of reactive programming and also of RX specification for all the languages. As you can see, we also have RxJS, we have RX Scala, we have RX Closure, even we have RX Swift, and also we have RX Kotlin. Well, in the same year, in 2010, also Node.js was created by Ryan Dahl. Well, this is he's the Node's father. And well, the sense of Node.js is that it's a single thread. The VNH engine in Node.js is only a single thread, but the powerful feature that we have inside Node.js is that Node.js, by its nature, is using non-blocking I/O. All the things are running inside of this publish subscribe pattern. We have events, and also we have subscribers, and we have publishers that are all based on events. So in April 2015, we have the first version of RX Java that are the basis of reactive programming for the different frameworks that we have in Java. And there is a specification. The reactive extension or for Java were created by Ben Christensen and also by Devin Carnock. Those guys were engineers at Netflix, and they work in the specification of RX Java. As you can see, we have 5 years of difference between the first reactive extensions for .NET and the reactive programming for Node.js based on the VNH engine. And until 2015, we have the first specification of RX Java. So right now we have the version 2 of RX Java that are based on these 4 principal interfaces. And well, we have, as you can see, we have the publisher, we have the subscriber, that let's say that are the most important interfaces, but also we have the subscription in order to check if we can request another subscription or we can cancel it, and the process that involves, and that is let's say that is the glue between a subscriber and publisher, and the processor is the interface that will interact between a publisher and a subscriber. Those 4 interfaces are the ones that we have in the specification on RxJava. And well, there are a lot of implementations. And one of the implementations is one that we will use in the demo, that is Reactor. So, well, if we talk again about Spring, Spring had a major release, actually a very important release on September 2017. In this year, it was released the version 5 of Spring, and well, the important, or as I said, was a major release because there were a lot of changes, and the two most important changes were the Kotlin support as an alternative language as Java, and we also have all the support for Reactor 3.1. That basically Reactor was a project that was created a few years ago, and was an independent project in Pivotal, and Pivotal engineers were working in Reactor in order to create Flux and Mono. Those two classes are basically the classes that have all the implementation of the specification on RxJava. And well, Reactor 3, as you can see, Reactor 3 was integrated as a core module inside Spring 5, that inside of Reactor we have all the things related with reactive programming. And well, also in Spring 5 was released the new reactive web clients for Spring MVC, and also Spring Data repositories that actually we will use it in our demo. And as you can see, we have support for Java 1.3 and 2.1. And well, as I said, was a major release, and we have a lot of different features and very cool features in Spring 5. And also, how it works. We talk about a little bit about Node.js, that it has a single thread, and also it's based on non-blocking I/O. Well, the sense of non-blocking I/O is based on an event loop. Yeah, the same event loop that we have in Node.js. And actually, inside Reactor, we have this same architecture. As you can see here, we have the CPU core, and inside of it, we have a lot of threads. But every thread inside of it has an event loop. And this event loop, as we can see, is checking for events. If someone sent a push event, pass throughout the event loop, and then try to check if someone is registered to a callback, we can work in intensive operations. We can have network operation, database communication, file system calculation, etc. And after that, those intensive operations were finished, we can pass a push operation inside, again, event loop, and the event loop will trigger a callback. So also here inside of it, inside Project Reactor, we have the capability to these callbacks and also the push operations could be sent in another thread. That is the sense of Reactor, and also the non-blocking I/O working inside of a Reactive project. And well, as I said, Flux and Mono are the two classes that have all the implementation of RxJava, and we will see it later in the demo. But something that I can say you, Flux is used for one of n set of data, and Mono is only used for one single data. And we will check it a little bit more deeper inside of demo. Okay, Spring Boot 2 that also born or was released on 2017 have all the infrastructure to work with the Reactive stack that we have hidden in the left. The Reactive stack basically is all the modules that will work inside of Reactor and also will work as a non-blocking web application or web framework. Here in the left, we can see that we have different modules and different infrastructure. First of all, we need to implement and Spring Boot have it out of the box a netty server. That this netty server will be the one for use non-blocking I/O containers or non-blocking I/O applications. We also have Reactive string adapters, and we have a very new module created for Spring Reactive, because since it's a new paradigm, since it's a new architecture, basically the Spring framework needs to be rebuilt or create all the infrastructure in order to support Reactive stack. And also we have a Spring WebFlux that is for web, and also we have Reactor repositories. If we can see the comparison between the new Reactive stack against serverless stack, we can see that we have equivalence there. We have the serverless stack that basically is the Spring MVC architecture that we know since 2002 that Roger also delivered, released Spring. And also we have a server container architecture that basically we are running a new web container with Tomcat, with Jetty. The difference between is that in Netty we have all the infrastructure for reactive programming, and we have blocking I/O inside Tomcat, inside Jetty. Well, we have the server API, we have the Spring Security, and also we have a Spring MVC, that is the equivalent of Spring WebFlux. And also we have the common Spring data repositories that use JDBC, APA, and also NoSQL. That is the comparison between that we have it before Spring 5, and that is the we have inside of Spring 5 and also Spring Boot 2. Okay. And well, the Spring architecture, or basically how all the things work together, is that we have the client, as you can see here, we have the client, and we have the request response that will be managed by the WebFlux controller. Here, obviously we have all the infrastructure for in this case, we can have maybe a netty server running inside of this. And when we receive a new request, obviously we will explode all the capabilities of reactive programming with Reactor and with WebFlux. We need to use Flux or Mono classes in order to manage the payload and manage the information that we are receiving, and also to manage the information that we will return to the client. Spring has a pattern for coding. We can have a service that basically is a class that has the at service annotation in order to basically the service annotation, and also a service class is the class that needs to have all the logic or the business logic for Spring applications. And then we have the repository. The repository, obviously we need to use reactive repositories, and those reactive repositories are communicated to the database. As you can see, we have all the reactive stuff throughout Flux and Mono that are the classes that were created to implement RX specification for RX Java. And well, this is the simplest architecture for that we have in Spring 5 and also that we have with Spring Boot 2. Something that we also need to say is that there are Reactor repositories and also there are non-Reactor repositories. We can mix the boot paradigms, reactive and non-reactive stack. But if you want to explode all the resources in our server and the computation usage, I really recommend you to use all the reactive stack. Yeah, again, we can also have JDBC here and a single or a common repository for JDBC, but we will lose a bit computation for using that repository. So something that also we need to add is that no SQL databases like MongoDB, like Cassandra, are reactive by nature. There are projects and there are modules that are running right now in order to have JDBC for not SQL, sorry, for MySQL or for SQL databases in order to have it working in reactive stack. Okay, nice. We have all the topics that we need to know, and we start working in a new application. So something that is very cool of Spring is that we have the capability to create a new application through our Spring Boot. And in order to create a new application with Spring, we need to go to Spring Starter.io. And we have this wizard, the Spring Initializer. Okay, the Spring Initializer is you used it before, and if you are not using it, basically it's a single wizard. We have the capability to create a new project with the dependencies, and also this send us a zip file that we will unzip it, and we will import it to your favorite ID. We will use IntelliJ, and we need to select the different modules, and also we need to configure our project. Okay, let's use a graded project. Obviously, we will have Kotlin as a language, and we will also select the version 2.3 of Spring Boot. That is the newest one. And here, we need to add the dependencies. Since we will use a Reactor project for Spring Reactive, we need to select, obviously, Reactive Web, that, as you can see here, is used to build WebFlux application with netting. Also, we need to add a Reactive repository. And well, let me select Spring Data Reactive MongoDB because right now I'm running a database, a single database inside of Mongo. And let me, before that, let me show you the thing that we will create. I have here a single React application. Basically, this application is very simple application. We will create a basic CRUD application for or to create a book. And well, this one I'm running it, and if I open here localhost for this application, we can see here, and inside the network, is trying to get information from an API from localhost 8080 API books. We will build this backend for this front-end application. And since it's running inside Mongo, I will select Mongo here as a dependency. And yeah, only we need to add those two dependencies. And let me create here, let's say, WebID. Let's have it in com. The artifact ID, we'll have it hello reactive. And the package name, I will change it to hello com.hello.reactive. Okay, let's generate it. As you can see, we are receiving a new archive file. Let me save it here. And I will open it. Unzip it. And let me open also IntelliJ. And we select here to import a project. And let me go to downloads, Reactive. We are importing this project as a Gradle, and we can click out next. I recommend you to use the Gradle wrapper and finish. It's very, very easy creating a new application with the starter projects of Spring. Is building it. As you can see here, we have the build Gradle project, and as you can see here, is building the project, is getting the dependencies, and is trying to build the project. But something important here is that we have the different dependencies for our project. And we have the starter project for MongoDB, we have the starter project for WebFlux. And well, if you used Spring Boot before and also started projects before, you can see that these started projects are the group of all, is grouping all the dependencies, all the started dependencies to create, in this case, a new WebFlux application to support Mongo repositories. It's very simple. We can see that we have a very clean dependency file. But if we go to the external libraries, we can see here all the jar files, all the dependencies necessary to create a new application. By adding only those starter projects is very simple. And awesome. Okay, as you can see, it's already built. Okay, let's create if you remember, we have this book application, and obviously we will create here. Let me create a new Kotlin file, and this Kotlin file will be our entities. Okay. Since we are using Kotlin, since we are using Spring with Kotlin, we will create a new data class. This data class, as I said, will be the class that we will use as an entity. If you are familiar working with Spring and also working with Hibernate and other object relational mapping frameworks, you know that we need to create a new entity in order to do the mapping between the database against object-oriented programming world. Okay, we create this new entity named book, and Data class is a very powerful feature of Kotlin that we create a new plain old Java object, let's say it in that way. We have a new object based on the properties, and we have the mutators and the get and server methods, and also we have the overridden by default the hash code, the equals methods that are used inside of a plain old Java object that we know it before, or we know it since always in Java. Okay, first of all, we need to add a new ID. As you can see here, the ID is an annotation from Spring Data. And obviously, we will create a new var named ID. And this will be a type of a string. Since the ID could be null, we need to explicitly say to Kotlin that we will null with question mark. With question mark, we say to Kotlin that this variable will be null. It's the only variable that we will use it as well. And then we also have, if you remember, we have the ESPN, we have the name, the author, release date, and editorial. Okay, let's create those properties. We have ESPN. This one also will be a string type. We have a name, again a string. We have name author, string again. We have a release date. And we will create a default date to do it faster. Obviously, here you can also mark it as a nullable type and maybe get information from the front end and process information to create a new date. And also we have the editorial here, editorial. And that's it. We have our data class and we have our entity class. That's all the thing that we need. And okay, I didn't create a package. Let me create a new package. New package, and I add model package, those entities. We also use the same file, this entity .kt file to create another data class, probably here, data class, and we can create another class here if we need other one. But it depends. Obviously, it depends of the size of your project. You can split it, or you can create inside of new Kotlin, the same Kotlin file. Okay, let me create another package. We will create the data class object package, and in this package we will create a new interface from Kotlin. This one will be our repository that we will have the communications to the our MongoDB or Mongo database. I will name it book repository. And here, to do an extension in Kotlin, we use a colon. And well, if you are familiar working with Spring repositories, we need to use a repository from Spring. But the difference between common repositories against Reactive repositories is that we need to import or to extend from a reactive, in this case, Mongo repository. And okay, we need to set the type. In this case, will be a type of book from our model and the ID for that repository. This interface, you can see here that we have present the mono and flux classes. that will be used inside all the Reactive stack. We have here the mono class that, as you can see here, the mono will use core publisher, and while core publisher extends from publisher that is based from Reactive streams, as you can see here, are from Reactive streams from RxJava. As you can see here, Reactor project use, as I said, the specification of Reactive streams. And well, that's it from our repository. Very simple, very easy. And now we will create a new package, and also we create a service class. And okay, we will create a service package. In this service package, we can create a new class from Kotlin. And we will use our book entity and our book repository. Okay, let's name it a book service. In this book service, we need to have an interface. As you are familiar also with Spring, you know that we need to create classes and interfaces, and all the things we need to build it oriented as a interface development. You need to create a new interface with the implementation in order to explode all the capabilities of dependency injection. And okay, we create a new interface. By default, all the classes, all interfaces, all the data classes are public and also the types are by default public in Kotlin in order to I don't use the access modifiers as we have it in Java. To do easily, Kotlin use all public. Okay, and we create this new interface, and obviously we will name it book service. And well, in this interface, since we are using, or since we are creating a new CRUD application, create, write, update, and delete, obviously we have the methods, in this case, the functions from Kotlin, to create all the operations for our book application. So, okay, let's go create a new function, name it save. This will receive a new book variable from mono type. As I said, mono is used for single data or for one data, and flux is used for more than one data. Since we receive a new entity from our client, we need to use a mono class. Okay, here we need to import our book application, and then this interface will return a new mono of book type. Cool. We also need to create one for load all records, and we don't receive anything. Obviously, you can receive here like a paginator between records, but that is for a more complex architecture, and we don't have so much time to do it. And for a demo purpose, we can use it here. We need to return a flux that will be a set of data, obviously all the records that we have in the database. And also we need to add another function that will receive a new ID from type string, and this one will return a new or the existing, if in the case of exist, a record. And obviously we need to add a delete method, so in this case a delete function that again will receive an ID to get the information and delete it from our database. And this will return a mono, but will return void. That is the type that will return. It's not returning anything, it's returning void. Okay, we also need to implement our class or interface here in our class. Let's use it, the most common name, obviously will be book service implementation that will be extending from our book service. And obviously, we need to implement the methods from our interface. Let's select implement members. Let's select all of them. And we have here our functions implemented. As you can see here, we have an override funct. That is the way that we are overriding a method, or in this case, a function from another interface inside of Kotlin. Something that also we need to include here is to add a new repository to get information from the database. So we need to inject to our auto-wired annotation, and we need to inject our repository. So there is another feature from Kotlin that is the late init bar. As you remember, we need to when a running type, a runtime, Spring try to create the beans, and we need to indicate to Kotlin that this bean will be created in part of that starting application. So that is the reason that we need to use late init bar in order to have the capability to have it as null in certain of time or certain window of time, and then Spring will be in charge of initialize that that bean. Okay, that is the reason that we need to use late init bar. And okay, we have a repository, and this won't be Reactive repository, will be our book repository. And with this one, we create a new variable that we will use it inside of here. Well, this will be very easy. We need to create a save method, and the save method we return. In this case, we need to create a flat map from our type that we receive. In this case, we will map it to as a new single type inside of our repository. And we here pass it or a flat map. We are doing here that we are doing here in our save method. And well, for loadout, only we need to return, or we can return the call from repository, and we return fin all. As you can see, Kotlin is not necessary to use a semicolon, and it's other thing that we can optional use. Okay, for load repository, dot load, no, is fine by ID, and we pass the ID. And here, we need to return, we can return actually the void type for delete by ID. We pass it. Awesome. We have our service class implemented. Actually, we can simplify it. We can remove a couple of things. Maybe we can remove this return, delete these braces, curly braces, and we can assign it as here. And as you can see here, we can have this logic in a single line. That is the very cool things about Kotlin. Since if it's a single line, the logic that we are doing, we can return it as here. Very, very simple. Okay. We also need to create, to finish, obviously, we need to create our endpoint. In this case, we need to create a new book controller. This will be a Kotlin class. In this controller, obviously, we have the request mapping annotation. request mapping annotation to obviously map or endpoint. Request mapping. And if you remember, we are calling to v1/API/books that we have here. That is the one that we will add it. v1/API/books. Other thing that we also need to add is obviously at the top is a REST controller in order to expose the endpoints. And other thing that we need to add and also will be used for demo purpose across origin annotation that will resolve that cross-origin issue that we could have because we are running a front-end applications in other port inside a local host. Spring by default is not recognizing this host because it's outside of Spring, and we need to indicate that we're recognizing that application as safe. This is a security topic, and also it's a security feature inside of Spring. So we are recognizing localhost in this case, 3000. Okay, obviously for production support and for production classes, we need to specify the host that we recognize, and also probably the methods. We need to configure a new security bean from Spring. But well, for a single, to get it started, we can do it in this way. Okay, again, we need to auto-wire or service class. In this case, I'm remembering that I didn't annotate it as obviously at service. With this one, we are created a new bean from Spring that will be a service, and we can inject it here again as a late init var, and we have our service from a book service. We need to create obviously the methods. And well, we create create, obviously. This create we receive throughout the request body. For request body, we will have a new book type that will receive it from Mono. As you can see here, the Reactive stack, and also well, Spring will receive the payload from the client and will convert it to a Mono type inside of our Reactive, in this case, our native server. And well, we need to return service.save, and we need to pass it the book. Let's annotate this as post mapping, since will be a new record inside of the database. And if you remember the REST principles, or the REST service principles, we need to use the different HTTP methods, and we are using throughout these annotations: post mapping, put mapping, get mapping, delete mapping. Okay, well, we will create a put mapping, a function that will be update, and this one will be the same. Now we need to add a get mapping to load all the information, and well, we create a fun load all. Again, you need to for bigger applications, you need to create obviously a paginator to don't return all the information from database because we can crash our application and crash our server. Okay, for demo purpose, we only return all the records from the database. Also, we need to create another get mapping, and this mapping will receive through path variable, throughout the URL, again, REST principles, a new ID in order to load a single record. In this case, we receive throughout a path variable, or ID of type string, and we return the call to our service dot load by ID. And to finish, let me copy this one because will be very similar, but will be delete mapping to delete a record. And well, let's change it. The name, delete, path variable, and let's call delete by ID. No, delete. Okay. Delete. Cool. We have everything to work in this to start this application. Well, since we are using Spring Boot, since we are using everything configured out of the box from Spring Boot and from started our starts project with WebFlux and also with Mongo, everything we will use it pointing to localhost. If you need to map your database for another server, you need to add it inside or properties file. You need to add that mapping here and using all the properties in the application properties. Obviously, for bigger projects, you can also use YAML files to map all the properties inside of our application. Okay, but since we are getting starting, trying to use Kotlin, Spring, and Reactive programming, we can use it all of the box, everything pointing to localhost. Okay, and as we can see here, we have the application, the Spring Boot application, that basically is some Java class that we have the main method to run all the Spring Boot application. That at the end, we will running a single Java application, in this case, throughout Spring Boot. Let me run it. We can check here that it's compiling the Kotlin files, because it's compiling the project and also it's building the project. And at the end, we need to be able to have records inside of here. And after the running, we need to be able to see those records. Well, it will take a little time because she's, again, building and created the application. Okay. You can also, as I said, simplify and do simple or class like here. If you delete, you can delete the braces and only return the information. It's a single line as we have it here in our controller. Okay, it's taking some time. It's starting the Spring Boot application. It will try to connect to MongoDB and also create the endpoints. Something that I missed here, and probably we need to restart the application, is that we didn't add our ID. So we probably would crash in the demo. Okay. Yeah, we have it. Refresh the page, we have data here. As you can see here, we have three files, three books. I really like those books. And we can add another book. We can use it as test, and let's assign a single date and test. If we save it, we have here. We can edit it and also test editorial. We can put it here. We have the update and also we have the delete. Okay, and very much that's it from this book application. So I think we can finish here. And well, if you have questions, if you have, since we are posting this YouTube, you can post those questions in the book in the channel, or you can also contact me here throughout my mail. Let me add it here. Is ocano@luxoft.com. If you have questions, I can respond to you those questions. Thank you so much for watching this video, and have a nice day.